Alrighty, this is going to be, probably need a little darker. This is going to be the video recording for Forces in Motion 3.1. And so this, we have activity 1 in Amplify, and we are going to do a reading, and then there's some questions in the notebook, and then there is activity 4 in Amplify and an exit ticket. So pretty short and sweet. So going to activity 1 in Amplify. You are going to notice when it loads that there is a message from Dr. Gonzalez, who is kind of our point person for our mission. And it is a bit of an update about what we've already figured out and things like that. And so the idea of chapter 3, because today's the first lesson of chapter 3, we're kind of moving into collisions and what happens when two things run into each other. And so here's what she said. So, thanks to you, we understand that even though the thruster force is the same strength on all pods, this pod was affected differently because it was more massive. The thrusters could only slow this pod, and since it didn't stop, it hit the space station. Our team is thinking about a rescue mission, but we also learned that the crash made the space station move. We know the collision caused the pod to move in the opposite direction, but is the pod faster, the same speed, or slower than the space station? How far away from the space station is the pod? How fast is the pod moving? Is a rescue mission possible? Once again, we need your help. And so here is a question down here based on the warm up. So if two objects crash into each other, what happens? Are both objects affected? How? And if there are any examples you can give. Think about when you've experienced or seen two things hitting each other, what happens? The next page is just the definition of collision, and that will be added to your notebook. So the moment when two objects hit each other. So if you have or do not have your Force in Motion notebook open, make sure you do that. A lot of people were asking me about what we added last, and the last thing we added was 2.3. And you can see down here I have noted that we did not do a notebook page for 2.4 or 2.5. And then today, all we have added on this first page is that definition for collisions. So the moment when two objects hit each other. And then we will look at our chapter 3 lesson 1 page, and you can see entering definition for collisions. And then down here, the next thing we're doing after that warm up is the reading. I have the reading linked here for you. The reading is also linked in our Canvas homepage. So that's there as well. And so based on that reading, which looks like this, you are going to read that and answer these two scenarios in the notebook. So I want you to describe a collision that happens in a game of pool. And I also want you to describe a collision that happens in bumper cars. And so you're going to kind of talk about that. And I want you to think about mass and how mass affects those collisions. And so you're going to do that. And remember, in these readings, you can use the little microphone, well, not microphone, I guess, megaphone, over here to play it, and you can listen to it if you would rather do that. Either way. And then there is activity 4 in Amplify, which I'm going to get to from here. So you are skipping activity 2 and 3 in Amplify. You do not need to use those. You are only going to submit 1 and 4. And so the idea of the homework is you're going to kind of explore collisions using the simulation. And they tell you to open it up, and here's the link for that, and select 3.1 homework from the menu. So when you have it opened up, I was already playing around with it. So if I go back to build, and I click rebuild, you can see over here in the menu, I scrolled, and you have to scroll down pretty far. So I scrolled down and I got to 3.1 homework, and it gives you kind of your scenario up here. So you're going to set up collisions between objects and observe the forces and changes in velocity. And like I said, in this activity over here, it gives you a lot of different ideas. So you can make a collision where the objects are running into each other, um, and they have the same mass. They could have different masses. They could have one moving and one not. So they give you a lot of different things over here. And so remember down here, these all are your different masses. So if I use this one, my object A is going to be my lightest, and then my object B is going to be my heaviest, and you can click run up here and prepare force and have them run into each other. So I can make object A run into object B and see that it literally just bounces right back off of it. Why does that happen? I can make it so that object B, oops, do not want that, but we can do that. So now both objects are moving in the same direction, and I can see that they're not going to collide because object B is way heavier. I can also go back to build, and I can add in a different object. So I can have two, let's do two the same mass. I could run it, and I could have them run into each other. I can do all kinds of things. And so your idea is just to play around with it and do a bunch of different options, and then record your observations down here about how forces exerted kind of change collisions. What does mass have to do with it? Does mass change your velocity? Remember, velocity is movement and speed. And so you'll do that. And so after activity 1 and 4, there's an exit ticket in Canvas, and then that is it. Remember, these slides are down here for you to use, so if you miss class, these are here for you to kind of follow along, and that's that.